Hi students, welcome to physics classes. Today we'll discuss about kinematics. Kinematics is a branch of mechanics. Kinematics is a branch of mechanics which deals with motion of the bodies without considering cause of motion. Kinematics is a branch of mechanics which deals with the motion of bodies without considering cause of motion. That is kinematics. Today we will discuss some basic terms related to kinematics. In that, first one, motion. Motion. For example, if a person standing at point A and another person B is at another point. One person is at point A, another person at point B. Now B is observing A. B is observing A. In a particular time t, A moves from one point to another point, A to C. With respect to this person, A changes its position to C from one point to another point. With respect to person B, A changed its position from one point to another point. That is, then we can say A is in motion with respect to B in a particular time t. So we can define motion when an object changes its position with respect to surroundings. Who is saying that A changed its position? B is saying at a particular time t1 he is at this point. After some time, at a t2 time, it comes to another point. So B is saying he changed his position. With respect to B, A changed its position. So we can define motion. An object changes its position. When an object changes its position with respect to surroundings. With respect to surroundings in given time. If you see, with respect to B, before t1 time, A is in rest position. After t2 time, he is at C in rest position. During t1 to t2, in this time, he is moving. So, in a given time, with respect to surroundings, A changed its position. So we can say A is in motion. Next, rest. Here, if B is observing A, at T1 time he is in this position. After some time T2 he is in the same position. Now it is not changing. A is not changing. A is not changes its position. With respect to surroundings in a given time. Before T1 we don't know what happened to A. After T2 what happened to A we don't know. During time T1 to T2 for a while, either 1 hour or half an hour or 10 minutes, either 1 minute, in that duration A is in rest position, not change its position with respect to B in a particular time. Then we can say A is in rest. If changes its position with respect to surroundings, it is in motion. Not changes its position with respect to surroundings, it is in rest. Next, motion and rest are relative terms. They are not absolute terms. They are relative terms. We can't say the object absolutely at motion, the object absolutely at rest. We can't say like that. With respect to particular surroundings, the object is in motion. Previous example we have seen. What we seen? A is at a point, particular point. B is observing. With respect to B, A changes to its position to another point. For example, O to O dash. Then with respect to B, A is moving, that we see. Another example, A not changed its position with respect to B. With respect to B, with respect to surroundings, we are saying A is in motion. Here with respect to surroundings, we are saying A is in rest. We can't say that absolutely A is in motion. Absolutely A is in rest. They are relative terms. I'll tell you another example in our real life. Then you can understand what is meant by relative. For example, if you take a person who is 5.5 feet. Now another person B is more height than A. Let us take 5.9 feet. Now with respect to A, B is taller. A is shorter. Another person came, C. He is 6.1. So with respect to C, B is shorter. As we compare B with A is taller. As we compare B with C, B is shorter. As we compare B with B is taller. As we compare B with C, B is shorter. We can't say B is absolutely taller. B is absolutely shorter. They are relative terms. Tall, short are relative terms. I'll tell you another example. Left or right. Now this is a path. One member standing on the path facing like this. For this fellow A, it is left, it is right. Now another person is coming in opposite direction. For this person it is right, this is left. So we can't say this is absolutely right, this is absolutely left. As the person changes its position, direction of view, this is also changing. Means based on the situation, if it is changing, the terms are known as relative terms. Now, like tall is short to left or right, motion and rest also relative terms. Now I'll tell you one example to show motion and rest are relative terms. Now there is a bus. In the bus, two passengers sitting on the chair. Let us take A and B. Now it is going on the road like this. It is moving, it is in motion. Let us take in our view. Now there will be a bus stand, bus stop. There C person is there. As the bus is moving, we'll take A. As the bus is moving, with the bus, A and B both are moving. Now if you see with respect to C, A is in motion. As the bus is moving, with respect to C, A is in motion. At a particular time the bus is here, at another particular time bus is here, another one time bus is here. So in that situation, with respect to C, A is in motion. Now if you consider B, with respect to B, A is in morning. 8 o'clock they started their journey. 8 o'clock he is beside. 9 o'clock he is beside. 10 o'clock beside. He is not at all changing its position with respect to B. So with respect to B, A is in rest. So a person in a particular time is in motion with respect to one surrounding, and he is in rest with respect to another surroundings. Now we are either in the school or in the home. We sat in the chair. We are in rest. We will think we are in rest. If a brother or sister or parents, if they are observing us, with respect to them, we are in the rest position. But earth is moving. With the earth, we are also moving. If any person observing from the space, we are in motion. Like this. They are on the earth. With respect to other persons on the earth, A is in rest. With the person observing from the space, A will be in motion. As earth is moving, we are also moving along the earth, no? Like that, we can say motion and rest are relative terms. Motion and rest are relative terms. They are not absolute. They are relative. Next, distance and displacement. First we will discuss about distance. Now, if a person started from a point A, travel to B, and then turns and travel to C, and then go to D. In this path he traveled. In this path he traveled. Now, what is the distance he covered? AB plus BC plus CD is the distance he covered. That means actual path traveled by the body or covered by the body. Actual path covered by the body is called distance. Actual path covered by the body is called distance. Now, while he is traveling from A to B, B to C, C to D, finally he traveled to A to D. Sum of AB plus BC plus CD equal to A to D. That is the distance. AB plus BC plus CD. Now, the shortest path between 2 points, A to D. The shortest path between 2 points. Shortest path between initial and final point. Initial and final point is known as displacement. Now here AB plus BC plus CD is known as distance. The straight path AD is called displacement. AB plus BC plus CD is distance. The straight path AD is known as displacement. Shortest path or straight path. The straight will be the shortest. That is displacement. Now, in distance, there is no particular direction. Here it is not having any particular direction. No direction. We can say A to B is direction is there, sir. B to C direction is there. C to D direction is there. But in this path A, B, C, D, no particular direction. Its direction is continuously changing. So we can't consider it is a particular direction. That's why distance is a scalar quantity. It has only magnitude, no direction. Distance is a scalar quantity. Now, in displacement, A to D, it is a straight path. It has direction. So, displacement is a vector quantity. Distance is a scalar quantity. Displacement is a vector quantity. Now, SI units of distance and displacement both are lengths. These two are simply a length. A to B plus B to C, C to D. Length of actual path. Length of shortest path. So both are having SI units. Meter, CGS unit, centimeter. Now, distance cannot be negative. Distance cannot be negative. Once if it started its path, one started a path, whatever the direction he is going, then it won't be 0. It is cannot be negative and it is not 0. It has some value, some positive value. It is always positive. If it starts its position, it won't be 0 and it cannot be negative. It is always positive. It is always positive. Now displacement. It can be 0. Even starts its position, it can be 0 when if he comes to initial position. If he travel in any path and comes to initial position, then displacement is a 0. Displacement is a 0. Now it can be negative also. When he started from point A, travels 5 meters in one direction and returns back, travels 10 meters, then his displacement is negative. His displacement is negative. Okay. Next, uniform speed. If a body, any vehicle starts from point A, travel to B and to C and to D. Now A to B it traveled 10 meters, B to C 10 meters, C to D also 10 meters. And every time it took to travel the 10 meters is 5 seconds. Now what is the speed between A to B? Speed is the distance traveled by the body in unit time. Speed means distance traveled by the body in unit time. Now here speed equal to distance by time taken. SI unit of speed, distance unit meter, time unit second, CGS unit centimeter per second. Now coming to here, the speed A to B 10 by 5 2 meter per second, B to C 10 by 5 2 meter per second, obviously C to D also 2 meter per second. Now in all the situation it is traveling with the same speed. It is traveling with the same speed. So here the body traveling equal distances in equal intervals of time. Equal distances in equal intervals of time, that is uniform speed. Then the body is said to be in uniform speed. Equal distances in equal intervals of time, then the body is said to be in uniform speed. Now the same body is traveling A to B, B to C, C to D. A to B 10 meters, B to C 10 meters, C to D 10 meters. Now here it took 5 seconds, now here it took 3 seconds, here it took 4 seconds. Now can we say the speed is same for A to B, B to C, C to D? No, it is not same. Then it is non-uniform speed. Non-uniform speed. So here we can say the body traveled equal distances in unequal intervals of time. Distances are equal, times are unequal. Equal distances in unequal intervals of time, then the body is in uniform, non-uniform speed. Non-uniform speed. Now another example we can take. Same A to B, B to C, C to D. Now A to B 10 meters, B to C 15 meters, C to D 5 meters. Time taken is 5 seconds. A to B, B to C also 5 seconds, C to D 5 seconds. Now here times are equal but distances are different. Distances are different. So we can say different distances, unequal distances in equal intervals of time. Body travel unequal distances in equal intervals of time, then it is non-uniform speed. If both are equal, uniform. If any one is unequal, non-uniform. Both are equal, uniform. Any one is unequal, that is non-uniform. Now, what if both are unequal? 10 meters in 5 seconds, 20 meters in 10 seconds, 15 meters in 7.5 seconds. Unequal distances, unequal intervals of time. It may be uniform or ununiform, non-uniform. Now 10 meters 5 seconds 2 meters per second, 20 meters 10 seconds 2 meters per second, 15 meters 7.5 seconds 2 meters per second. Now if it is 10 meters 5 seconds, 20 meters 7 seconds, 30 meters 8 seconds. Now here also different, but it is non-uniform. Here it is uniform. So if both are equal, based on the situation we should say, not with the definition. Either one is unequal, it will be non-uniform. If both are equal, it will be uniform. Speed. Now, uniform speed, uniform, non-uniform speed we see. Now, uniform velocity. Instead of saying the speed and velocity separately, I am including it in the uniform velocity. Velocity means displacement. In speed we have taken distance, in velocity displacement by time taken. Displacement by time taken. SI units meter per second, CGS unit centimeter per second. Like uniform speed, non-uniform speed, velocity also uniform velocity, non-uniform velocity. If a body travels equal displacements in equal intervals of time, equal displacements in equal intervals of time, then it is uniform velocity. If both are equal, equal displacements, equal time. If any one is unequal, if any one is unequal, that is non-uniform. That is non-uniform. Any one unequal, that is non-uniform velocity. Now here, velocity we are saying in terms of displacement. Speed we are saying in terms of distance. Now velocity also we can say in terms of distance. If a body travel equal distance in equal time in the specified direction, if a body travel equal distance in equal time in specified direction. What is the difference between distance and displacement? Direction. Distance, no direction. Displacement, direction. Now, if the body travel equal distances in equal intervals of time in a specified direction, that is uniform velocity. Uniform velocity. If distance, there is a direction, it becomes displacement. So we can say uniform velocity in terms of distance also. If a body travel equal distance in equal intervals of time in a specified direction, then it is uniform velocity. Uniform velocity.